So we said when I have theta, that means theta is either less than what? 90 degrees. So whereby if you look at our right angled triangle, this one, we shall have the hypotenuse, we shall have the opposite, and what? The adjacent. Now the adjacent is always the base line. Then this one is always the height what? Height line. So this is the baseline over there. So this is the height what? Height line.
Yes.
So this is the height. Then the other one is the hypotenuse. So we can easily find the hypotenuse using Pythagoras theorem, which says a squared plus b squared is equal to c squared. So should I continue explaining yesterday's one?
Yes.
Okay. Now we shall look at so we look at the downer thing there. So we said when we say trig functions, they are what we call ratios. Do you know what you call a ratio? A ratio is a division. Is what? A division. So either we have maybe, let's say, 1 out of 2. That is a division. So 1 out of 2 is dividing like this corner here. So 1 out of 2, then the ratio is 1 to what? To 2. Then we said from our simple method, we have our method which we are going to use. So common, Our method says SOHCAHTOA. Yes, a simple word we shall memorize. SOHCAHTOA. SOHCAHTOA means this is now the sine of a given angle, the cosine of a given angle, then the tangent of a given what? Angle. So when I say SOHCAHTOA, it means the sine is opposite. This is the O. Opposite over what? Hypotenuse. Then this is adjacent out of what? Hypotenuse. Then this is opposite out of what? Adjacent. Is that okay?
Yes.
Then we looked at them down. When we say ratio, that means they also in division form, like this one. Sine alpha, if the angle is what? Alpha. Sine theta if the angle is what? Theta. That means opposite over hypotenuse. It is a division, so it is a ratio. Then cosine, it is from adjacent out of hypotenuse. So we have this one also what? A ratio. Then tangent, which is tan, theta. Opposite over what? Adjacent. So we are using what we call the SOHCAHTOA rule or the SOHCAHTOA method. To allocate these ratios now. Then from there we said we have this triangle here. It must be at 90 degrees. So it must be at what? 90 degrees. So we shall say, so at 90 degrees, from this one I have A, B, and C, meaning our B is the opposite. Over there, the A is the what? Is the adjacent. The C is the what? Hypotenuse. So when we say sine from SOHCAHTOA, it is the B, which is the opposite out of what? C. Then the tan is B out of what? A. Cos theta, now A out of what? C. Whereby this is the angle, and these are the trig functions. What we call the trigonomical ratios. Is that okay?
Yes.
Where you get lost, you inquire,
Yes, teacher.
Okay. Now we're given an example here where we are started using the what? The numbers, but still this is 90 degrees, this one. That is 90 what? Degrees. So suppose you're given 6, 4, and what? 5. Those are lines. But these lines are making us an angle what? Theta. So whereby this is the hypotenuse, the 6. This is the what? The adjacent, and the what? And the opposite. But there's something which we must know. The angle must always be with the base, not the height. Have you got it? The angle must be with what?
Yes.
The base, not the what? Not the height.
The base.
That means it must be like this. With the here, not with the what? Or height over there. This is wrong. When you say theta is here, this is what? Wrong. Theta must be where? There. With the base. What you call the horizontal. So we look at finding the angle. Suppose you're looking at angle, or we're given what? So looking at the angle. So finding the angle, so we have like this. Maybe from sine, you can either use sine, or you can choose tan, or you can use what? Cos. So this time I use the sine here. So I say the sine theta, which is from SOHCAHTOA, opposite out of what? Hypotenuse. Then for getting theta, which is our angle, we shall say sine inverse of this 5 out of what? 6. And we say the sine inverse, we get it using a calculator. You first press 5 out of 6, then you go to second function in your calculator. It is up there. Either they say shift, then press what? Sine. When you say shift, press sine, you get something like this. I think you're right. I see where I'm right. So we shall be getting something like this: sine inverse of what? Of 5 out of 6. When you press your calculator. Do you have your calculator there?
No. You have a
Okay. So when you press shift, then it will bring that. Some phones have standard calculators. That symbol is always there. That's the second function. Or shift, then sine. Okay. Then you get the angle. So the angle we got was 56. So our angles are recorded in 1 decimal place. Are recorded in what? 1 decimal place. 1 decimal what? Place. Okay, then should we continue? So we had that example there. We had that example there.
Yes, teacher.
Okay. I see that example. Example 1. So our example 1, we had the 9 meters as the opposite. Then we had the 5 meters as what? Adjacent, and 6 meters as the what? Hypotenuse. But remember, we don't have C. So the best way how we find the C is using Pythagoras theorem. So how do we determine that? We say we use what we call a squared plus b squared is equal to what? C squared. This is the formula of Pythagoras. So you can easily get the C. So they say find the C, find cos theta, find sin theta, find tan theta. What do you get in your C? What is your C? What is your C?
Still calculating.
Okay.
Teacher,
Yes.
it is
You connect, huh?
12.
It's 12, eh?
Yes, 12.
Okay, let us see what we got. So first we got 10.6. How did you get it from? Remember, it is a squared plus b squared is equal to c squared, yeah? So we have 5 squared plus 9 squared is equal to c squared. 5 squared is 25. So
Yeah,
where
I
did
saw 6 here.
so it's not okay.
Yeah.
Okay. So what then from there we just substitute, eh? Hmm? Okay, suppose it is maybe okay. Let us use that yours. 6.
Yes.
Okay, if I use 6, so this is it. 6 that is 36. 36. 36 plus what? Plus 81. What do you get? Okay, what is your chief? 12, eh? What is it?
Yeah,
12.
so let's use the other one.
5, eh? Okay.
Yes.
So this is 5 meters. So this is also 25, eh? So that means
Yes.
this is 25. So when you get your C was 10 point what? 0.3. That's the hypotenuse, no? So that means in case you're going to find the cos, you say cos is from SOHCAHTOA, no? So from SOHCAHTOA, you have that formula there. This is a key formula you must understand. Very key. SOHCAHTOA. Then cos is adjacent, which is 5 out of what? Out of 10 point what? Is it? That is your cos of theta. Have you got it? Denise, how are you?
I'm okay, sir.
Okay, we are trying to look at yesterday's work, before we link in for today's work. Okay. So from there we saw that. So we looked at that. Then we looked at finding the hypotenuse, cosine. Then we had this example here. So here I was telling you that you must know what we mean by the horizontal. So the angle must be horizontal. So if you look at this angle, I mean, this is your base. This is the adjacent, this is the opposite. So they may trick you around. Have you got it, Praise? Praise, have you got it? Okay. So we look at those various steps. And then we have looked at that example there. That example. Okay. So we said we have 16 and 48. Now our base is what? 16. So this is the base. Then the opposite is what? That then from SOHCAHTOA you substitute. But you need to find C first. So our C is what? Our C is 16 squared plus 48 squared is equal to C squared. Therefore, C squared is equal to root of what? 16 plus C. Well, this is squared and what? Squared. That's what we have. Are we clear? No question from the previous now?
No?
Okay. So, but I left you with some assignment. I don't know. There's some people who never submitted their work. Denise, you never submitted the work.
So which work? Yesterday.
Yes. I sent you on groups on WhatsApp.
But I thought it's just for trying out in what? Now on free time, not for handing in.
But even if you mean you never got a challenge in all those.
No?
Eh,
Yes.
no challenge, eh? Okay.
Yes, sir.
Now we're going to try out this one, then we see. Huh? So are you seeing my screen?
No?
You don't see my screen, okay. Okay. Are you seeing it now?
Yes.
Okay. Now we are understood. You're going to try for me this one. And try for me this one. Very simple but tricky. Very simple but what?
Tricky.
That's why I'm saying tricky, tricky. Do for me example 1. This one. So try that, as I hope Shamila to connect